Great, then let's start. Welcome everyone to the fifth lecture on requirements engineering, today covering the topic of functional requirements. And with that, we are entering the specification of functional properties and capabilities before discussing the specification of non-functional properties and capabilities in the next lecture. So before we start, as always, let's briefly recapitulate what we did in the last lecture. In the last lecture, we discussed generally the perspective we take when getting started in a project. We covered briefly the general idea of requirements elicitation, and more importantly, how to get started when using an artifact-centric approach as the one reflected by AMDIRE, which we are using in this course. And we covered the first two content items of AMDIRE, namely the stakeholder model structured by shared viewpoints or views, which represent common interests and intentions with the software system, and both together answering the question, who is interested in a software system? And we discussed goals and goal models as a means to answer the question, why they are interested and what their interest exactly is. Along the goals, we briefly touched upon the idea of goal refinement as a means to infer requirements from the goals, as a means for problem scoping, as we say. This is what we tend to do by asking how questions and what questions, or what do you mean by the system shall be secure, just to give one example. And we discussed also briefly the general idea of abstraction as a means to identify the requirements rationales reflected by their goals. Now, what we left open is where to go from here on, what to do from here on, in particular, how can we capture functional properties of a software system, but also to which levels of abstraction does this relate, and most importantly, what are the underlying modeling concepts that we can use for that. You might have heard some of those modeling concepts, some of those terms, such as use cases and scenarios, but also functional requirements or user stories in context of Agile. So an interesting question is, how do these different concepts relate to each other? And this is exactly what is in scope of today's lecture. We will be focusing on two different topics, not different, related topics. One of them being, we want to understand how the general notion of functional behavior relates to different levels of abstraction, the ones we capture in AMDIRE. And we want to address three relevant content items to specify this functional behavior, namely being the domain model that captures the operational context of a software system, the system vision that captures a joint unified vision about what is inside in our system and what is outside of our system, capturing the boundaries of a software system and the major use cases I want to support with my software system. And finally, the usage model, which serves as the content item for the functional requirements, capturing all these different complementary, as we will see, modeling concepts ranging from use cases and scenarios over user stories up to functional requirements. Now, before starting, maybe a small disclaimer. When it comes to the specification of functional behavior, the literature is literally full of different approaches, thousands of approaches, of definitions, specification templates, representation techniques, notations, and so on and so forth. Now, the good news here, in contrast to non-functional requirements, as we will see, the good news is that there is a certain consensus, there's a certain agreement between all these different definitions, which gives us the privilege to take a more pragmatic perspective and concentrate really on the essential concepts, so how these different techniques relate to each other. So this does, as always, not replace the importance of having it done at least once, of having applied all these different techniques at least once to learn what the different pitfalls might be, but also to learn what might be actually rather easy, maybe in contrast to a complex definition. And this is, as always, in scope of the hands-on sessions, the lab sessions, and the project Q&A sessions. There's a second disclaimer I would like to make before I forget. As you will notice, not only today, but also in the next lectures, there are some content items in the AMDIRE model we will not discuss. Um, One example being a service model or a data model, risk list, there are many. The reason is quite simple. The very idea is that I don't want to overwhelm you, but rather concentrate on the essence. So once we understood how to specify functional requirements, once we understood how to specify non-functional requirements, the rest comes easy, and we can look all the information up. For example, how to specify a data model, because it's very much related to the notion of functional property. Another reason is also that many of these content items are addressed typically in requirements engineering, but they are not really in scope of requirements engineering, and therefore also out of scope of our course. These content items serve the transition to the surrounding disciplines. The risk list, for example, serves the transition to risk management. The functional hierarchy serves the transition to architectural design. So you will find further readings related to those content items or extended slide sets that shall give you a big picture and shall illustrate also how all these topics that we discuss in this course, how these relate to the subsequent development phases, such as architectural design. This is for the curious reader under you, which I know is every one of you, but nevertheless, these are meant to capture more excursions so that you see also in other courses how the things that we discuss in this course relate to those courses. Now, let's directly start. Today, we will focus on three topics. Number one, we will be discussing how this general notion of functional behavior relates to the different levels of abstraction in AMDIRE, before then discussing the single content items, the domain model, the system vision, and the usage model in more detail. This is exactly then the point where we will be opening the little windows of our Advent calendar and look inside these content items. So let's first discuss this general notion of functional behavior and how it relates to the different levels of abstraction. And here I will be iterating a couple of times through the very same levels of abstraction. And I might, to some extent, maybe sound a little bit like a preacher or a politician, I don't know. But rest assured, the idea is not to turn some baseless claims into truth, into facts, but rather than giving you different perspectives on the very, I shouldn't have said this, giving you different perspectives on the very same concepts so that you can wrap your head around this. So give it some time, give me some patience, and you will see how straightforward actually functional modeling intends to be. Now, let's directly start by jumping into the cold water and discussing what is a functional requirement. So what you can see here is the definition by Davis, which is one of my favorite definitions because it's very straightforward and up to the point. He says that a functional requirement describes the external user-visible black box behavior on a software system characterized by a stimulus, by an input, and a reaction, a response, or an output. And it's simple as that. It's an external perspective on a mathematical function. I throw something into that function, the function processes something, and it gives an output. In terms of requirements engineering, I specify what reaction I want to perceive from the software system when giving it a stimulus. So I want to describe essentially what reaction I, as an external actor, it can be a human being, but also an external system, what I, as an external actor, expect from the software system when interacting with that software system. So typically, you find functional requirements in the form as represented on the bottom of the slide, a natural language specifications following certain patterns, and one form or the other saying when there's a certain condition, when I deliver a certain input, the system shall do something. When I press a button or when I use my search engine, when I type in a search query, I want the system to deliver a certain response following certain characteristics without restricting the solution space, without saying how exactly it should process my input. So this is the very essence of a functional requirement, but there's much more to it. And one thing to understand is that this very general notion of functional behavior includes different levels of abstraction, some of which don't even consider a software system at all. So always keep in mind, software is built by humans for humans, and those humans who intend to be supported by a future software system, they operate in a specific context. And this context is typically characterized by workflows, by tasks that they want to achieve, by procedures that they want to follow in a business, for example. And one specific task in requirements engineering is to understand that context and to infer requirements towards a software system so that this software system fits that context, which brings me to the different levels of abstraction. Now, the levels of abstraction that you can see here, you know already. So we distinguish the context layer that gives answers to the why question. So why do we need something? We have the requirements layer that specifies user visible characteristics of a software system. So what should be done? We have the system layer that specifies how it will be implemented, the glass box view on a software system. So in the context layer, we capture typically the goals and the operational context with no immediate relationship to the actual system and its usage. So what we do here is we capture our understanding of the real-life operational environment and all those tasks that need to be accomplished when making use of a software system. So for example, all those tasks that I might find in the banking sector. Banking processes, for example, when opening a bank account or when registering a user. Now, in the requirements layer, we capture the user visible external black box perspective on the system behavior with immediate measurable, that is testable, relationships to the actual system. So here I specify how I, as an end user, intend to interact with the software system in context of my tasks in order to accomplish those tasks. In the system layer, then I capture the system functions and the internal realization. So here is when I describe how my software system should be realized in order to support those intended interactions. Now, a couple of other terms that you might find in literature is that the context layer is often characterized as business requirements, because very often we describe the operational business world, the perspective on the workflows, on the tasks. For the requirements layer, very often the term is user requirements is used because we describe user visible characteristics of a software system. And the system layer is very often called system requirements because we discuss here the what at a system level. Needless to say, I'm not a big fan of those terms because the system level requirements or system requirements somehow suggest that we are still talking about requirements engineering when in fact we are talking about the solution space and rather design activities. Now, let's go through this picture again, but this time we will put focus on what we actually do and the underlying modeling concepts. Now here you can see again the context layer, the requirements layer, and the system layer. Now in a first step, I tend to analyze the domain in the operational context. I want to understand what the typical workflows are, what the typical tasks are, which stakeholders are involved, what their goals might be, but also what the more operational environment, like what are the external systems that might or may not maybe play a role in that system. Now, here we concentrate on really understanding what the typical workflows are. For example, when opening a bank account. In a second step, I want to infer and specify the user visible behavior in the form of requirements, in our case, in the form of functional requirements. And to this end, I'm relying on what we call the usage model. Here, I want to understand how I, as an end user, intend to interact with the software system in order to realize certain tasks in a system-supported manner, which means that for some of the tasks, I decide that maybe those tasks remain the responsibility of an end user. Other tasks, however, might be in scope of a software system. So for example, when I try to authenticate or to verify my user identity in a bank, I might process some information, exchange some information, and my usage model here exemplarily visualized with an interaction diagram. Here I specify how I can do this with a software system. So I enter certain credentials maybe, and the system processes those credentials. In a third step, I prepare for the transition to the solution design, to the solution space, where I identify those system-sided actions, those system-sided functions, and I further refine those functions into what we call a functional hierarchy. So at this stage, I decide which sub-functions do I need, what structure would I like to include, which means what could the interfaces be that I might offer with my software system, how can I further refine it into a logical and later on a technical component architecture, and so on and so forth. So this is clearly in scope of design activities. Now, let's go through this again, and this time we focus on the content items of AMDIRE. So when the first step, when I analyze my domain in the operational context, when I want to understand what the real life environment is of my future software system, I specify the domain model. Now, the domain model captures my understanding of the operational context of my software system, represented by different views I can take on the domain. One is a workflow view, another one is a more static view on the objects that might be important in the domain. I will show you this in more detail later. In a second step, I infer what we call the system vision. The system vision is the means for communication and for scoping, because it defines what the boundaries of my software system are and what the major use cases will be that I want to support with my software system. In a second step, I infer and specify the user visible behavior, which means that for every use case that I indicate in my system vision, I infer a usage model in the form of interaction scenarios that captures how I as an end user intend to interact with my software system. And in the last step, I identify those system-sided actions, those system-sided functions, and I refine them further as a means to move on to the solution space. Now, let's go through this once more, but this time with a little bit more detail. We'll be looking into the actual content items. And again, we will be relying on our banking example using our beloved ATM. As always, always keep in mind that how exactly we specify our contents, our content items, but also what notation we might want to use, very much depends on the project context. So keep in mind, we will be talking about business processes, but not all systems need an understanding of business processes. Some of them don't even have business processes, but more on this later. Now, let's start again with the domain model. As I said, the domain model captures our understanding of the application domain and the system environment. So here I want to capture what the real life operational environment of my system under consideration is. And I can do this by capturing two perspectives, and which perspectives I take very much depends on the application domain and, more importantly, on the underlying family of systems. So typically I focus on workflows, on tasks that human stakeholders might want to perform and which human stakeholders might want to have in a system supported manner. So a classic example for this are information processing systems or business information systems. This is what I typically found in domains that are heavily dictated by workflows, ways of working, tasks that I want to achieve. An app, for example. I want to achieve a certain task with my app, and this is typically characterized by these more dynamic perspectives that I can take on my domain. The other perspective that I can take is a more static perspective where I try to understand what the operational environment is, what the objects are that are processed. Both perspectives are rather complementary, but the second one tends to be more important in domains that are more dominated by a hardware view and a software view. So embedded reactive systems, for example, in the automotive sector, where many of my software systems don't interact with human beings, but rather with purely external systems. Now, what you can see here is one example for a dynamic view captured by a business process modeling notation. What exactly we do here is not that important, but take away one thing, that is that at this level, I don't specify how I intend to interact with the software system, but rather I really want to understand only what the generic workflows are in my domain. Maybe another note on this occasion is in literature, very often you find approaches that say that you should start by modeling the as-is status. the way that currently is the business is carried out in an organization, the workflows that are carried out in an organization. Then from there on, do maybe a gap analysis to infer the to-be status, the future status. Just take one note with you that if you do it that way, that tends to be an own project. Important is that the domain model captures the intended status, the to-be status, the idealized view on the workflows we would like to have supported. Now, once I have understood which tasks should be accomplished, I can start thinking about my system vision. Now, the system vision fulfills essentially two purposes. Number one is to provide an overview of the immediate system context. So I want to define my system boundaries, what is inside and what is outside, and the most important use cases to be realized. As I mentioned earlier, the system vision is an excellent means to scope our overall project by saying what will be part of my software system and what is not part of that software system. And again, I can have two different views on my system vision. One is focusing more on the context, and the other one is more focusing on a big picture of the key functionality that I want to offer with my software system, typically captured by a what we call use case overview diagram. So what you can see here is a more context view. Important is that I outline my boundaries of my software system and the relation to the operational context. It can be actors in the form of human beings. It can be actors in the form of external software systems. And I outline key features that I want to offer, that I want to provide with my future software system, some of which are in direct relation to my external operational context, others maybe not. Now, once I have understood those major features, those major use cases, I can infer my usage model. So the usage model I use to analyze the system behavior from the perspective of my external users. It can be human beings or external systems via intended interaction scenarios, which means that for every single use case that I identify in my system vision, I infer how I want to realize these use cases in the form of interaction scenarios. So again, we have different concepts here at our disposal. Sometimes I can specify my use cases with structured text, with templates. I can use them. I can use interaction models, proper models for my interaction diagrams. I can use also user stories and so on and so forth. How exactly we will be discussing later. What you can see here is an example for a human activity diagram that captures how I, as an end user, intend to interact with my ATM in order to realize the use case I've provided in the system vision, but more importantly, in order to realize my general workflows in the domain model, the task that I have understood before that. So, for example, I can describe here how I, as an end user, intend to authenticate with a software system by using my debit card and a PIN. This is the point where I really start taking the black box perspective on my software system. Once I have understood how I intend to interact with the software system, I can identify the first major functions in my software system, which brings me to the last step, which is the functional hierarchy. Now, the functional hierarchy takes those system-sided functions and does nothing else than a change of perspective. So, for example, in context of a use case where I authenticate as an end user, one element in my activity diagram could be that the system should verify my identity. Now, in my function hierarchy, I just leave the perspective of my end user on this system-sided activity and take the perspective of my software system and think about which functions do I need to provide. So user verification, for example, instead of saying verify user, I turned it into a function called user verification. This change of perspective is the change of perspective in the roles in our engineering process. This is the change of perspective from a requirements engineer to my software architect. And this is the way how I start my transition into the solution space, by inferring a functional hierarchy, which you can see here at an example, a simple example. I decompose it into further sub-functions. I start thinking about what the typical interfaces might be, the static interfaces, talking about data types, the semantic interfaces, talking about more detailed interactions, the logical component architecture, and so on and so forth. So this is the last time we will be talking about functional hierarchies, because they are clearly in scope of fostering the transition into the solution space. It's good to have heard what it is, but it's outside of the scope of this course. Now, in this context, I've created a small additional slide set. It's an excursion, because I want you to have at least the opportunity to look into how to do this transition from the requirement specification into architectural design, how these things fit to each other, how the general notion of a component or an interface relates to what we specify in requirements engineering. But again, take this more as an outlook into what to consider in the design activities, which is clearly in scope of other courses. Now, let's move on to the actual content items. So most of the things I'm telling you now in a second will come at no real surprise to you. But still, let's look into these content items and think about what to specify. And let's start again with the domain model. Now, what is the definition of a domain model? A domain model captures the most important types of objects in the context of the system. It represents the things that exist in real life, the things that exist, or the events that transpire in the business environment. So reflected by this definition are already the two complementary perspectives I can take on my domain. As I mentioned earlier, some of the domains are heavily dictated by business processes, by workflows, by tasks I need to achieve. This is what you tend to find, for example, in the finance sector or the retail sector, which we take as a running example here. Others rather not. These others are more dictated by static views, by objects that I might have, by sensors, for example, by bus systems, by more infrastructure-related perspectives. Now, what is important? It's important to understand that not all domains are the same, or not all domains are represented the same way, but all domains require the same level of dedication to understanding the domains. And this is in scope of the domain model. Now, let's consider just two simple examples, first on the dynamic view and then on the static view. What you can see here is a business process model capturing a more dynamic view on my domain. A business process serves the understanding of real-life workflows, which may or may not be partially supported by the system under consideration. Here it becomes already clear that when I capture my understanding in a domain model of the workflows I might want to support, that not everything that I will model will be in scope of a software system. More importantly, when I capture these workflows, I focus really on the essence, on my understanding about those workflows, but I do not yet at this level specify how my software system is intended to be used in this context. This is in scope of the usage model. So after specifying my domain model and after inferring my system vision, this is what I model in my usage model. And I do this in a couple of steps. As I mentioned earlier, the first step is really to understand what those workflows are. I identify the major activities that are carried out in a bank, for example, the information that is passed from one activity to the other, and so on and so forth. For example, what information I need to open a bank account. So what information I might get from a user or a customer in order to open my bank account. And I can do this typically by doing observational studies, but very often you find these descriptions already in organizational documents that capture the very essence of their workflows, that specify the rules of the domain, the business rules that need to be applied. For example, how to calculate interest rates. All these information are typically, at least for larger organizations, are typically captured already in reference documents. Now, in a second step, when elaborating the system vision, I identify what we call candidates for use cases. So I think about which of the workflow elements or which of the excerpts in my workflow I might want to support with my software system. And in a third step, I specify how I want those workflows to be supported by using my software system. And I do this via the interaction models. So I say, for example, which of the tasks should be done by the end user, for example, when registering or opening a bank account using a web-based application. So what the end user has to do, what is the information that he has to enter in my software system, and what are the tasks that remain in the software system. So for example, how do I identify myself? How do I specify my bank ID, for example? And this is in scope of the usage model, and this is in scope of the modeling activities that I tend to do when conducting my requirements analysis. Okay. Now let's focus on the at least briefly on the static perspective. The static perspective captures or is represented by an object model that serves as a conceptual model of the elements, the things that are important in my problem space, the things that have a certain relevance to the business domain, for example. Let's stay still at the example of a banking sector. In my object model or in my static view, I typically focus more on the elements that might be important, the information elements that are important, and their proper meaning, the semantics. For example, I can specify what a bank account or a customer account consists of. What is the information that my bank needs in order to process opening a bank account? But again, same as with the business process models, I do not focus on how I might want to use my software system, but rather what these elements might be. And some of which might be later represented in my data model, others maybe not. This is a decision I take later. Not all domain models need to be captured via a proper model, as you can see here. Very often you can achieve very good results by capturing the most important elements of the domain in a spreadsheet, for example, capturing a glossary that explains really which elements are in scope of a object model and which not. And here again, we focus always on the essence, those things that are really important to understand the actual domain, the operational context. Now, a couple of words on my system vision. So the system vision is a joint vision of the system under consideration and its interrelation with the operational context. Again, I focus on two things. I want to understand what the boundaries of the software system are. So what is inside of my project and what is outside of my project. And I specify what the key functionalities of my software system are in interaction with its context. I specify what the elementary use cases are that I want to support with my software system. Keep in mind, the system vision is the entry point into the software requirement specification and is the ultimate means for communication and scoping. And very often it's part of an agreement and even a legal agreement. So you will find one way or the other represented in one way or the other, a system vision as part of the contracts that specify what to do in an engineering project. Now, what you can see here is the relationship between the system model and the key features that I want to specify in my usage model. The upper view focuses more on the boundaries and the relationship to the operational context. The lower one is which you know as a use case overview diagram. And you can see here already that many of the ways of representing my system vision might want to use complementary diagrams, but in some cases we can merge them just to one because they are very, very similar. And this very much depends on the complexity of a software system and the project. So if the complexity is low enough and it allows, I can focus just on my use case overview diagram because it very well represents already the relationship to the operational context. In other cases, however, not. Regardless of how I specify my system vision, important is one thing: it needs to be easy to communicate, which brings me to rich pictures. So what are rich pictures? Rich pictures are a simple drawing of my context and what is inside and what is outside. Rich pictures is a perfect way to reduce the complexity, the technical complexity of a system vision. At the same time, rich pictures doesn't really follow specific rules, if I want to say so, specific semantics of specifying this operational context, but it's rather a simple creative drawing. From an engineering perspective, formulating something as a rich picture might be a little bit counterintuitive, but they serve a specific purpose. They are easy to communicate. When I first saw rich pictures, I should add that I thought that this is really not what we should do in requirements engineering as an engineering discipline. I was one of those who were propagating the value of goal-oriented requirements engineering, of using more formalized views, because those formalized views allow us for precision, for mistakes. I can model the system behavior in more mathematical terms, in more precise terms. I can simulate those models, but at the very end, nobody really understood those models. So I was one of them, thinking like Bob Ross. This is a little bit of an esoteric way of specifying my operational context. Let's prefer more the formalized use. But again, I realized at some point that nobody really understands those complex formalized views, which brings me to the value of rich pictures, which brings me to the point where I started rejecting those goal-oriented requirements engineering approaches, those more formalized views I can take on my models that might very well be suitable from an engineering perspective, but not from the perspective of the stakeholders that need to understand the system vision. And this is where rich pictures come into play. Now, at this very example, what I capture in my rich picture is a car sharing app. So car sharing means that I, as an end user, can take my mobile phone, for example, my app. I can locate a free car. I can book it. I run to the car. I take the car, drive through the city, park it somewhere else for the next user to use. And those car sharing applications tend to be rather complex. And in this rich picture, I specify essentially three things: the overall context with all the entities I might encounter that might play a role for my car sharing app, distinguishing maybe the business context and the operational context with the users. I clearly define the boundaries of my software system, and I identify the major functionalities, the major use cases I want to offer by their relationships to the external entities. For example, that a user needs to register with this web-based app, or that I need to be able to advertise through my app. So this is just one example for rich pictures. You will find on Canvas a paper as a further reading on how to use big pictures, rich pictures, and some recommendations on how to approach them, what to include, and how to visualize these elements. From there on, you will find some more tutorials that give you many examples. If you just look up the term rich pictures, you will find many examples on how to draw them. And I want you to play around with rich pictures and try them out at least once in your project. You will see what the benefits are. Now, this brings me to the last topic of today, which is the usage model. Now, let's start with a very small example and an open discussion, also and as a means to take a small break. As I mentioned earlier, to specify a usage model, I have different complementary means. I can do this in different ways. I can use use cases and scenarios. I can use user stories, or I can use functional requirements. I will explain what the differences are later. Before doing so, however, I would like you to reflect about why even bother. So why are usage models so important in requirements engineering? And I would like you to take two perspectives. One perspective is the one from a requirements engineer. So why is it important in requirements engineering? But please take also other perspectives from the surrounding engineers. So for example, why is it important for solution engineers? Why is it important to management? I would propose the following. Let's take a small break. Let's make it a 10-minute break. Use the first 5 minutes to let that sink in what we discussed now, and then take 5 minutes to put some thoughts into the importance of a usage model. Grab a piece of paper, grab a pen, grab a cup of coffee, or maybe a cup of tea, and put some thoughts into this, and then we will discuss it in 10 minutes. Let's start again. So, what do you think? Why is a usage model important? Let's first start in requirements engineering, the obvious one. What is the purpose of a usage model? What do you think? Exactly as you said. I couldn't have said it any better. The ultimate purpose is to understand user visible functionality from the perspective of end users in order to achieve their tasks. So, and this is the ultimate goal, to provide a basis for correctness. So this is the whole point, that I have a basis and against which I can specify my software system, implement the software system, achieve correctness. So remember the very first lecture when we talked about these criteria, among them correctness. I want valid requirements, and the system, the usage model is one way of achieving that. It's the way of achieving that. Very good. So, but let's now change maybe some perspectives. What else in the software development lifecycle might matter? So think about also the very first lecture when I explained that requirements engineering is an interface to several activities in the software lifecycle. So they have multiple subdisciplines that might make use of those requirements. So think about the workflow in my engineering. Who might use those usage models else other than the requirements engineer? So what is the purpose for their perspectives? Think of an architect. Exactly. So before that, it supports clearly the transition to architectural design. So an architect might use the usage model, as I've indicated, with a functional hierarchy, might build such a functional hierarchy, infer some identify the critical functions, implement them, infer an architectural design, and at the end of this, I want to test my software system. I want to test to which extent it really satisfies the requirements and to which extent it is correct, to pick up what you said earlier. And this is in scope of acceptance testing. Exactly. And here we will see the clearer my interaction scenarios are, the clearer my usage model is, the easier the job of a tester. The easier is to follow exactly those intended scenarios and see if my software system really enables those interaction scenarios. Other purposes that come to my mind, more obvious purposes that come to my mind is, once I have understood my usage model, the key functions, key features that I want to provide with my software system, I can, from a planning perspective, I can do effort estimations. If you consider the general project organization and management of a software project, software development project, the effort estimation is something I tend to do based on an activity-based notion. Use case points is one such example. It's one such example for an approach for effort estimation. But also when doing, not speaking in terms of Agile, when doing my sprint planning and thinking in terms of planning poker, I use the usage model, the user stories, to plan the effort necessary to implement certain features. At some point, I can even make or buy decisions. I can think about, what do I need to develop from scratch, custom software? What can I maybe reuse? What can I buy? So there are multiple decisions that all, in one form or the other, rely on a clear understanding about how future end users intend to interact with my software system, the usage model. Now, let's look to the left side of this figure and we see different concepts. What we will do now is pulling all these concepts apart from each other. And let's start by talking about what the difference is between a use case and a scenario. Now, a use case integrates all possible scenarios which might occur when an actor tries to achieve a specific usage goal. So a use case is an abstraction of multiple scenarios. An example for a use case could be user authentication. And that's it. This is all the information I need, user authentication. Now, a scenario describes an ordered sequence of interactions between the system and a set of external actors in the form of users or external systems. Now, A use case abstracts from a set of different scenarios. The use case is what is in scope of my system vision, a short and pithy statement that reflects major functionality of my software system. The scenarios is what is in scope of my usage model, where I want to understand the steps that need to be performed in interaction with the software system, therefore in scope of the usage model. So user authentication could be one use case, and the scenario describes how this user authentication should be performed. Let's take from this, move on from this more meta model perspective that you find in AMDIRE and the concept model to proper examples. So in my system vision, I tend to specify my use case overview in one way or the other. This doesn't really matter, but I specify what the major key features, the key functionality that my software system shall offer will be. And this could be in the form of a use case overview that captures the major use cases that are of importance for my development project. One such example could be withdraw money or money withdrawal. I tend to use substantives here. Or opening a bank account or user authentication. So these are typical examples for my use case. And every use case has a name, a goal, and a context of use. The context of use described already here by setting it in relation to my operational context. Now, for each use case, I describe a set of different scenarios. What you can see on the right side is one way of doing so. We have seen this template, the use case template by Alistair Coburn, already when we spoke about requirements engineering approaches, where we showed the general notion of templates. So this is one example for a use case template. Here I specify for each use case with a proper name, a context of use, and a goal, which scenarios shall be supported. I tend to have maybe some primary scenarios and some alternative scenarios. I have multiple scenarios that I can specify in my use case model. So the left figure would be part of the system vision. The right one would be part of the usage model. Now let's talk about use cases and scenarios again, but taking a different perspective. What you see on the left side is a use case following this natural language description using a template. On the right side, you see different models that serve the purpose of visualizing the very same, the different interaction scenarios. You see it in the form of an UML activity diagram, or the other one would be an MSC, a message sequence chart. So all these three things describe the same, same. And yet they are different. What's the difference? When I specify my use case using natural language, this technique tends to be a little bit error prone. Natural language makes us quite often abstract too much. Maybe I have little gaps here and there, which I don't really spot when reading through a use case template, especially when they become really complex. When transferring them to models, which is in scope of requirements analysis, think of the lecture on requirements elicitation, where I first in elicitation workshops specify my use case with a first sketch, a natural language. Once I transfer them into proper models, this is the point where I can check if I have really understood what this use case is about. I can check what the workflows are. I can maybe capture a larger complexity in more simplified models, and I can see if there might be something potentially wrong or missing steps. This is the purpose of modeling in requirements engineering as part of the requirements analysis. Now, let's distinguish again all these different concepts from the perspective of use cases. So again, both are essentially the same. Both describe a use case and included interaction scenarios. Now, the use case is the set of all interaction scenarios that I might have. So a use case has a name, and it abstracts from all the different ways I want as an end user to interact with my software system. A scenario is specific interaction sequence in that use case. So here, for example, I can describe the scenario, the basic scenario, the primary one that I want to do in interaction with a software system in order to authenticate myself. I insert my debit card, I get prompted and asked for my PIN, I insert my PIN, and this is it. I have authenticated. That being said, both capture multiple scenarios. So an alternative scenario might be incorporated on the right side that describes what happens if I enter my incorrect PIN, for example. So I have multiple scenarios, multiple ways of going through this interaction model that are all part of the same use case. Now, a functional requirement is one specific response to one specific stimulus. It's just one exchange, one input and one output. It's just a small part of a scenario, which brings me to the concept of functional requirements. A functional requirement is a single atomic step. It's a single atomic interaction as part of something larger, an interaction scenario. And important is here to use them always with care. Don't specify them redundantly to the use cases. If you rely on interaction models, when you specify, for example, activity diagrams or interaction models in the form of natural language use case descriptions, there is no need to specify, in addition to them, functional requirements. So I would always focus only on the most essential ones, those that are not really obvious and those that are not already captured in my interaction models. All of them still part of the content item usage model. If I specify them, think again about the importance of using the models as a means to communication. We tend to specify them using natural language specifications, which brings me to the patterns. There are a multitude of different patterns, natural language patterns, sentence patterns, how to structure the sentences. One of them provided by the so-called Sophist group. You can look them up, of course, yourself, but in principle, they just provide some structure to how to formulate sentences that capture functional requirements, starting with a condition. So when I do something, when I give a certain input, when I push a button, when I insert my debit card, the system shall, should, or will do something. This relates more to things like requirements prioritization. We will talk about this during requirements management. Good. There's one concept left open, as we have discussed already. It's Agile. So what about Agile, for example? What about user stories? Which brings me to the artifact-centric view of Agile. So what is part of Agile and what is not? So one of the claims that is very often made is that Agile doesn't pay attention to documentation, and this is not right. We did once a study and analyzed which artifacts are actually implicitly specified in Agile methodologies, among them Scrum is one such example, and we came up with a proper model with 26 different artifacts. Among them, those that you can see here, those that are in scope of specifying functional requirements. So Agile, or the statement that we have quite often in practice, at least, that Agile emphasizes working software over documentation. Yeah, I mean, they do, but still there's a lot of documentation to be done, because also here we need to communicate certain things. Now let's look at what artifacts are in scope of Agile when specifying functional requirements. Here again, you can see different levels of abstraction implicitly captured in Agile approaches. We want to distinguish 4 major levels. One of them is called the themes. This is what the top level objective or the goal of my software system is. An epic is a high-level functionality represented by a group of user stories. So it abstracts from multiple user stories to one. You can probably already see where I'm going with this. A user story itself is a brief statement of intent when interacting with the software system. So here I take again the user perspective on the interaction with the software system, and a task is an implementation unit for developers and testers. In our case, it would be a feature, something that I tend to define during the sprint planning implementation units. Now, let's map this on AMDIRE, and again we have the very same top-down view ranging from the themes that correspond to our objectives and goals, high-level goals, usage goals in this case, epics that are an abstraction of multiple user stories, therefore the same or equivalent as our use cases, the user stories that capture the interaction scenarios between the end user and a software system. Therefore, they are part of our usage model. And finally, the tasks that represent more to our solution space, the transition into architectural design, which means that from a conceptual perspective, the user stories and the use case descriptions, so the scenarios of a use case, are essentially the same. So one such example, I've shown you the template already when talking about requirements engineering approaches. One example could be an interaction scenario from the user perspective, saying that as a customer, I can define my own PIN, that logically what everyone wants, that I can use the same password again and again for every system I use in the internet. Now, from a conceptual perspective, it's the same as a scenario that I capture in a use case. But the difference is that it's the level of granularity. User stories are short, pithy statements that are easy to digest, but they abstract from a couple of information that I tend to have when I describe my use cases. For example, primary scenarios, alternative scenarios. This is typically in scope of testing. So when I rely on use case models, I make the life of my testers, those who decide if my software system is correct or not, much, much easier. It's much more measurable. At the same time, not everything needs really a use case description, because not every information is so difficult to perceive that I really need to transfer them into models. There are many, many occasions where a user story is more than enough. Now, and this brings me already to the conclusion of today. We have seen a couple of content items that we can use to specify functional requirements, among them our domain model that captures the operational context, the system vision that captures the scope of a software system, and the usage model that captures how I, as an end user, intend to interact with my software system to capture functional requirements. And we have seen that we have multiple ways of specifying those. And what I would like you to do after the lecture, let the information sink in, brainstorm and think about what might matter to your projects, and let's discuss them, as always, in the hands-on sessions. It is really important that you have applied the different concepts at least once, so that you can see what really the pitfalls are typically, what the challenges are, but also what are the rather easy parts, so that you get a feeling for the different ways of representing the contents. Now, before concluding, a final word on the use of models. We have spoken about this, I think, from different occasions, but let me just reiterate on the importance of models. Models in requirements engineering, or using models already in requirements engineering, is a wonderful means to do a proper analysis, a proper requirements analysis. And the more detailed my models are, the better the questions are I can ask. Also, precise models enable us from an engineering perspective to do a multitude of things like tracking requirements. I can set models in relation to each other, can define consistency rules, and so on and so forth. I can identify to a certain extent conflicts, resolve those conflicts, and so on and so forth. At the same time, it's always important to make a trade-off from a cost-benefit perspective. The more detailed the models are, the more labor-intensive they are to elaborate, to create. Sometimes we tend to specify models for really trivial tasks where we don't need models, where we should rather rely on more easier, in the sense of easier to digest and more lightweight to specify description techniques, such as user stories. And at the same time, of course, the more complex the models are, the more difficult they become to understand, especially from the perspective of non-technical stakeholders. Now, and with this, I would like to end today's lectures. Thank you very much. It's time for questions and discussions, if you have any. Okay. Then I would say see you all in the next lecture on non-functional requirements. In the lab session next week, we will be addressing what we have learned today and giving one specific example, as I mentioned, so that you can specify it at least once and see, get a look and feel into the concepts we have introduced today. So thank you very much. Take care, everyone, and have a good day.